everybody, and welcome to ARE Live. I'm Chris Hopstock, Architect Education Specialist here at Black Spectacles and your host for today's ARE Live. We're going to work through several mock exam questions from the PPD division with Black Spectacles virtual workshop instructor Marissa Yee. We'll focus on the preliminary design of sites and buildings, design concepts, and various codes and regulations. We'll also answer any of your burning PPD questions with a live Q&A session at the end of the episode. If you're joining us for the first time, Black Spectacles is the first ever NCARB approved online test prep provider for all 6 divisions of ARE 5.0. Our test prep materials include video lectures, practice exams, quizzes, flashcards, and virtual workshops with a variety of membership options available either for individual architects, firms, AAA chapters, or schools. If you're curious about how you can get your whole firm on a membership and have your boss pay for it, go to blackspectacles.com and head to our firm pricing section. I'll share that link in the chat. We're also the first test prep provider to offer an ARE guarantee. If you use our expert membership to the fullest and you don't pass the ARE, we'll pay for your retake. I'll share that link in the chat with more information as well. We're releasing new and improved study content all year long. We've already added section quizzes for all 6 divisions of the ARE, and we revamped our construction and evaluation materials. Up next is practice management. We just released over 100 brand new PCM flashcards, giving some extra attention to firm financials and business structures. These flashcards are a sneak preview of our new PCM videos that we'll be releasing in the coming months. Black Spectacles is also expanding its offerings to help architects thrive throughout their entire careers beyond test prep and software learning. We'd like to extend an invitation to join Spectacular, their professional network built specifically for architecture and design. Create your free profile today to check out our job board, add your portfolio of work, and explore our curated collection of projects from around the world. I just shared the link to sign up for Spectacular in the chat as well. Join us on October 20th, 2022 as we review questions from the PA, PPD, and PDD divisions. We'll focus on solving complex math questions that you'll come across in these 3 divisions. Our expert discussion with returning guest Haley Pugh will include a live demo of how to effectively use the whiteboarding calculator for these multi-step math problems. We'll also offer a live Q&A session to answer any of your mathematical questions. We'll be sending out a mock exam link in the coming weeks so you can test your knowledge before going over your answers live during the broadcast. I'll post the link to register in the chat box in your GoToWebinar control panel, or you can go to go.blackspectacles.com/ARE-live to sign up. Today we'll be engaging exclusively in our online ARE community. If you think of any questions you'd like to ask Marissa in our live Q&A session, be sure to post them there. You can either click the link that I just shared in the chat box or find it in the ARE Live section of our ARE community homepage. Everyone who posts in our thread today will be entered to win a free Black Spectacles t-shirt, so head over to community.blackspectacles.com and just say hi. Don't forget to stay tuned until the end of the podcast to see if you've won. I shared the link in the chat box and you can find it in the episode description if you're listening after the broadcast. We'll be sharing Marissa's screen during today's live, so we recommend watching the webinar to better see how Marissa works through these questions. The episode will be available in both podcast and video format after the airing, so to get the full experience, you can watch the video on our website, blackspectacles.com, then head over to resources and then ARE Live podcast. Without further ado, I'd like to welcome our guest, Marissa Yee. In addition to being a virtual workshop instructor with Black Spectacles, Marissa is also a licensed architect in Hawaii and California and works at Gensler in San Francisco. So welcome, Marissa, and with that, I will hand it off to you.
Thank you, Chris. All right, let's get started. An architect is working on a historic renovation project during the preliminary stages of design. The project includes removing the rear wall of the building to make room for an addition. A new 16-foot long, simply supported beam will be added, and the team has determined that it has 2 loads acting on it. They are a uniform load of 200 pounds per linear foot and a point load of 600 pounds 4 feet from the left end of the beam. What is the reaction at the rightmost support of the beam? Round to the nearest pound. Okay, so we got a classic building structures, simply supported beam question. So the words simply supported indicate to us that the beam has only 2 reactions. There's also no mention of the word cantilever. If it was a cantilever, that would mean the beam would only have 1 reaction. They don't provide a sketch in the question itself, so it would be helpful to sketch this out. So I'm going to show that to you right now. So this line is representing the beam. We have our reaction on the left, so I'm going to call that RL for reaction left. Then we have our reaction on the right, so I'm going to call that RR. And this is the one that we want to eventually find how many pounds it's supporting. So we're really going to pay attention to this right reaction. Okay, now what makes this question tricky is that we have both a uniform load and a point load. So I'm going to draw both of these out. We have our uniform load here. So when we have a uniform load, think of it as like a blanket of snow, an even blanket of snow covering a roof or something like that. It's just even, it's uniform throughout the entire object it's acting upon. And this is 200 pounds per linear foot. So I'm going to write that in here. All right, and then we also have the point load of 600 pounds, 4 feet from the left end of the beam. Because this point load is offset, meaning it's not directly in the center of the beam, this means the amount of load that each reaction is going to pick up is actually going to be different based on its distance from the point load. So we have a point load of 600 pounds. That is 4 feet from the end of the beam. And then our beam itself is 16 feet long. All right, so we've sketched out the basic parameters of the question, and it'll help us clarify the 2 different loads, which is what makes this question so tricky. Okay, so I'm going to enter a new page, and to sort out our thoughts, I'm going to write uniform loads here. So we're going to look at each load separately, and then we'll add them together at the end to find the reaction at the rightmost part of the beam. So to find the amount of uniform load each reaction picks up, we can just multiply out the load and then divide by 2 since it's evenly distributed. So going back to this, remember our uniform load is the 200 PLF, it's evenly distributed, so we can just divide by 2 because each reaction is going to pick up the same amount of load for the uniform load. So we're going to do our reaction right, and I'm going to add a little subscript U for uniform load equals our uniform load, which is 200 PLF, multiplied by the length it's acting upon. So it's acting upon the entire length of the beam. So that would be 16 feet. And then we're dividing by 2 because the left reaction and the right reaction each pick up an equal amount of load for this uniform load. Okay, and then we're going to use our calculator here. So we have our reaction right for the uniform load. Let's multiply this out. So we're doing 200 PLF times 16 feet, which is the length the uniform load is acting upon. We have 3,200 pounds, because pounds per linear foot times feet is just regular old pounds, and we're dividing that by 2. So 3,200 divided by 2 is going to be 1,600. Scroll down here. So reaction right just for the uniform load is going to be 1,600 pounds. So we know that this right reaction is picking up at least 1,600 pounds of load. Okay, great. So we've finished the first part of this question, thinking about the uniform load. Let's open a new page and think about the point load next. So organizing our thoughts and labeling this page as point load. Okay, so this point load is going to be a little trickier. Again, I mentioned earlier, because the point load is offset, as in it's not acting directly in the middle of the beam, the amount of load that each reaction takes is going to be different based upon its distance from that point load. And so the way that we can help ourselves calculate this is by doing something called taking the moment. So taking the moment is just a fancy way of saying multiply the load we are considering, so that's this point load, by its distance from the moment point. So just multiply the distance by the load. And then by taking the moment, at this leftmost reaction, we can essentially cancel out this variable of the left reaction that we don't know. And that's because if we take the moment at this left reaction, the distance of the reaction from that point is 0, so it's essentially canceling out. Then we can focus solely on the rightmost reaction, which would be 16 feet away from the left reaction. Okay. So the proper way of writing the equation is the sum of all the loads at the left reaction. So I just wrote a summation symbol and then reaction left is 0. And the reason why it's 0 is because nothing is moving. In the laws of equilibrium, all the loads are being picked up by the reactions, nothing is in motion. So that's why we have 0. Then looking back at our sketch here, remember by taking the moment, that just means multiply the load by the length it's acting upon. So we have our point load of 600 pounds and it's 4 feet away from the left reaction. So we're going to do 600 pounds multiplied by 4 feet. Okay, and then because the point load is pointing down on our beam and the reaction is pointing up on our beam, by convention, we need to indicate one as negative, acting in the negative direction, and one is acting in the positive direction. So because they're acting in different directions, we're going to call this right reaction negative. So I've written a minus sign here, and then we have our right reaction. I'll actually call it right reaction P, so we don't get things mixed up here. And that is, again, 16 feet away from where we're taking the moment. We're taking the moment right here. So 16 feet away. Okay, great. We have our big equation written out. Now let's simplify things a little. So we have, I'm going to move this right reaction here over to the left side, right reaction for the point load, multiplied by 16 feet equals, now I'm using the calculator, 600 pounds times 4 feet. So we have 2,400 pound feet. Great, we're inching a little closer. Okay, now it's just divide by 16. So we have our 2,400 pound feet. Divide that by 16 feet. And we have our right reaction for the point load is 150 pounds. Great. So we just found the reaction at the right reaction for the point load. We've already found the amount of load that the right reaction is taking for the uniform load. Now to find the total load, we'll add these together. So again, organizing our thoughts. For the total load, we have our right reaction is equal to the right reaction for the uniform load plus the right reaction for the point load. That was 1,600 pounds plus 150. Using our calculator again, we have 150 plus 1,600. That is 1,750. All right, and there's our answer. So we have 1,750 pounds at the right reaction. You would type this in here, 1,750. And always good to double check to make sure your units are in sync with what's being asked of you in the question.
Yeah, thanks, Marissa. That was super thorough. And I think as you can see from watching Marissa go through this, is that a question like this really takes some practice. I mean, you've got to be comfortable with a lot of these subscripts and just the naming conventions of structural calculations to be able to do this efficiently. And I would definitely say to do this on the ARE, it takes a good amount of practice using the whiteboard and calculator efficiently. So I would encourage you all to practice with those tools. You'll also notice that Marissa decided to, write these things out using the sketch tool instead of using the text tool, and that's totally okay. There's not a right way or a wrong way to do this. I think she did that because all the subscripts are challenging, if not impossible, to do well with the text tool. So it made sense for this question. But if you remember from our July ARE Live with our virtual workshop instructor Haley, she used the text tool to write everything out. So it's really personal choice, but I would definitely recommend trying a bunch of different ways to solve problems like this using the tools that you have available so that you can do this efficiently on test day. I'll also say that this question, obviously you need to know what simply supported means in order to answer this question. Otherwise you can't even sketch it out as Marissa did to start the question. There's also some, you need to know what uniform and point loads are and sort of how to translate the text of this question into a diagram. So practice that so you're comfortable with it. Understand how to recognize fluff in a question, the fact that this is a historic renovation project and this is the rear wall of a building. It really is immaterial to the answer here. All right, Marissa, take us on to number 2.
Awesome, thank you. And good tips there. Definitely find what's comfortable and what works for you. Okay, next question. An architect is designing a new construction hotel project with 60 guest rooms, a restaurant, and a lobby. The architect is working with the mechanical engineer to make recommendations on the HVAC system for the project before an upcoming meeting with the client. The client has expressed a preference for all water systems. Which of the following systems should be recommended? Check the 2 that apply. So our possible answers are closed loop heat pumps, active chilled beams, fan coil terminals, constant air volume, variable air volume, and hydronic gradient heating and cooling. So when selecting an HVAC system, we should consider several factors, and these include building type, building size, client preferences, and sustainability. We have some of that information scattered throughout this question here. We know that the building is a new mid-sized hotel with a few additional ground floor programs. Hotels often need a lot of flexibility between rooms. Since I'm originally from Hawaii, I always like to make my rooms super warm, but other people might want cooling while I want heating. And then even beyond that, other rooms will be vacant and will have the HVAC off. So you need a lot of flexibility there. The ground floor restaurant and lobby will require additional HVAC flexibility. Hotels often have a typical floor plan, which makes it easy for HVAC elements to stack between floors. Cleanliness is also important for hotels, with Legionella and other bacteria posing continued risk as hotels age. One of the main things we notice here in the question is that the client has stated a preference for all water systems. In the exam, this is definitely something that I would highlight with the highlight tool. This statement here will likely eliminate any air system options. Sustainability could also be a determining factor for which systems should be recommended. For example, a packaged terminal unit or through-the-wall unit could work for a hotel since each room has individual needs, but using multiple units is not as energy efficient as a centralized system, which a lot of these options are. With these needs in mind, let's go over the different system types. Okay, so first, we're going to go over closed loop heat pumps. So closed loop heat pumps are an all water system. Pipes will circulate chilled water from the chilled water plant in the summer, or heated water from the boiler or other overheated areas like restaurant kitchens in the winter. The heat pumps blow indoor air over the chilled or heated coils. Individual rooms can affect the flow of water to the pipes, regulating the temperature. And while humidity cannot be controlled, this is overall an efficient system. This is actually a good choice for our hotel because it provides both individual control and it is an all-water system. So we're going to check this one for now. We can always come back later if we feel like something else becomes a better option. All right, next we have active chilled beams. So active chilled beams include both air and water system elements and can perform heating or cooling. outside air is treated at a central fan room, then ducted to individual floors and rooms. Chilled or heated water from the boiler room or chilled water plant is then piped to each individual floor or room. At the room, the supply air is mixed with existing room air, then blown over the pipes to heat or cool the air. This system can be individually controlled, influencing the flow of water in the pipes. Since this is not an all-water system, we can eliminate this option. So on the exam previously, I liked to use the straight-through tool for options that I knew were definitely incorrect, just so I could get that off my mind and not have to worry about it. Okay, so we're not going to check active chilled beams. Next, we have fan coil terminals. This is an all-water system. Heated or chilled water is piped from the boiler room or chilled water plant to fan coil terminals at each room. The fan coil terminal pulls in both outdoor air and existing room air, then blows it across the pipes. Because each fan coil is pulling in outdoor air, this needs to be located on an exterior wall. Not having to duct air around the building does save space. However, the humidity of the air cannot be easily controlled because you're mixing in outdoor air and existing room air. Each fan coil terminal is individually controlled, adjusting the flow of water to the pipes. This is therefore a good choice for our hotel since it provides individual control and is an all-water system. So we're going to go ahead and check this for now. So even though I mentioned earlier that the humidity of the air cannot be easily controlled, making this option maybe not so good in some cases, there's nothing in our question here that mentions anything about humidity. So we can ignore that fact for the purposes of this question. Okay, if perhaps you were constrained on time on the exam and wanted to move on to a question, you might want to do that at this point since you've already checked the two that apply. If you had more time or if you're going through and checking all of your answers, you would definitely want to go through the last three. And we're going to do that here on our area live. So for constant air volume, abbreviated as CAV, it is similar to VAV in that it is a centralized air system with heated or conditioned air ducted from a fan room to each floor and room. However, the volume of air that is supplied to each room is universally controlled, making it a better choice for a convention center or assembly space. Since each room is unable to adjust the air individually, this is not a good option for hotels. We would not select constant air volume in this scenario. Variable air volume is actually very similar to constant air volume. It is also a centralized air system. Again, heated or conditioned air is ducted from a fan room to each floor and room. Occupants can decide how hot or cold to make their room by adjusting the volume of heated or conditioned air that is supplied to their room. VAV is a good choice for hotels because it does allow flexibility. However, the client has expressed a preference for all water systems, which you see in this last sentence here, so we can actually eliminate this option. If the question didn't mention anything about this client preference, then I actually would have checked variable air volume as a possible system for a hotel. And then lastly, to round things out, we have hydronic radiant heating and cooling. This is an all-water system ideal for large spaces. Piped water is heated at a boiler or cooled at a chilled water plant, then piped to each individual room. Instead of being piped to a unit at each room like fan coil terminals or closed-loop heat pumps, the pipes themselves are embedded in the floors, walls, or ceilings. Heat is radiated from these pumps to heat the space, or if cooling is required, the surrounding heat is transferred to the cold pumps, removing heat from the space. Because the air itself is not being treated, humidity cannot be controlled. Furthermore, the surface under which the pipes lie cannot have any thermal resistant materials. This means that if the floor itself is heated, it can't have any carpet on it. And we know that in hotels, carpet is pretty standard for many rooms. While this is an all-water system meeting the client's preference, this system is actually intended for large spaces, making it not ideal for a hotel application. So we would not check hydronic radiant heating and cooling. So we have our two answers here, closed loop heat pumps and fan coil terminals. There are actually a couple ways you could have approached this select two that apply question. We went through each answer individually for the purposes of this ARE Live and then eliminated them one by one. However, there are quicker ways that you could approach this on the exam. One way would be to consider which systems are ideal for hotels and then cross out any that are not ideal for hotels for whatever reason. And then the other way you might have wanted to approach this question, which is actually how I might have approached this on the exam, is to eliminate anything that isn't an all water system. In my opinion, it's easier to remember which category system it is versus if it's a water system, an air system, or a mixed air and water system. I think that's easier to categorize than trying to remember which system type is best for which building type. And then if we did try and eliminate things by what is and isn't a water system, it would have narrowed things down to just 3 options. I think
yeah, that's exactly what I would have done as well. I think that's a good strategy for this type of question. And this is another question, kind of like the first one, where you obviously need to know some vocabulary terms, and it's obviously useful to be able to say a little blurb about each of these systems headed into this exam, and maybe even being able to sketch out what these systems look like. So I would definitely familiarize myself with all of the HVAC options before this exam. But just moving, talking about Marissa's tip there to just consider the all water systems. If you could reduce this check the 2 that apply question to just 3 options, you're in really good shape, even if you don't have any idea what systems are better for a hotel or whatever type of project the question that you're answering is talking about. One tip I can give if you're answering this question and you just didn't read the part of the book or you didn't watch our video that talks about this is think about hotels you've been in. I mean, have you ever been in a hotel with a hydronic radiant heating cooling system? I've never been in one, but I've certainly been in hotels with heat pumps and fan coil terminals. So, you can kind of apply some just living experience, and maybe if you've designed hotels, maybe they've used one of these systems. So, using process of elimination can help you use your experience to answer some of these questions. All right, question 3.
Awesome. An architect is working on the roof plan of a proposed flat plate concrete 19-story multifamily residential building and is coordinating the structural design with the MEP equipment that will be located on the roof. The roof level is located at the maximum allowable building height per the local zoning ordinance, but mechanical equipment and supports are allowed to be higher than the maximum building height. The specified emergency generator is a good deal heavier than originally anticipated, and the structural engineer advised the architect that the current 8-inch thick slab is not adequate to carry the load. The generator is located between columns and cannot be relocated. The penthouse unit is below, and the owner is concerned about maintaining the ceiling height in that unit. There will be no dropped ceiling. Which of the following solutions addresses the structural issue and is most cost effective? Our multiple choice options are: add an additional column beneath the generator, add downturned concrete beams beneath the generator, increase the depth of the slab, or add steel dunnage above the roof. Okay, so we're going to sketch out a few things here. So here we have a flat plate concrete system residential building. That means the floor slab is just a single 8-inch slab of concrete with concrete columns. Looking at it from below, we have our 8-inch slab of concrete. And then we have our concrete columns. All right, so that is the structural system type that we're working with. The portion of the question that mentions the building height and the mechanical height being at different elevations is actually something that I encountered on the project recently. In that project, the zoning stated a maximum height allowed for that building's city and area, but there were additional negotiations we did with the city which allowed the mechanical equipment to be higher than that, so long as it was protected by a screen and set back from the building edge. So to kind of sketch that out in elevation, it says 19 stories, but I'm not going to draw 19 stories here. We'll just do a little section here, pretend that's 19 stories, and then we have our MEP equipment on the roof here. And then in plan, this is speculation because we don't have all of the information, but there's probably some sort of equipment, maybe an air handling unit. And then we have our emergency generator. And maybe it's, well positioned between columns and can't really be relocated. All right, so a little bit of background. During SD and early DD, it is actually common for mechanical engineers to estimate the weight of certain equipment. The structural engineer then bases their calculations off of this weight. However, in this question, now that the emergency generator is much heavier, this is now too much load for the 8-inch slab the structural engineer originally designed. So let's go through each of the options and discuss why they are or aren't appropriate. All right, so we have add an additional column beneath the generator. This actually does seem promising initially as a way to take on the new load of the emergency generator. However, this creates several ripple effect ramifications. The load from this new column will have to continue down the rest of the building. So let's say we wanted to add a column like right here to help support our emergency generator there. If we did that, the load from this new column would have to actually continue down. So that was diagonal. Let me try that again. The load would actually have to continue down the rest of the building somehow. You can't just create a column and not support it as the load continues down the building. So this would either mean you'd have to thicken this floor slab down here to support that new column's load, or you may have to add a beam under that floor slab, or you might have to add a column at that location on each floor. So you'd have to do a bunch of other things to help support this new column. That's probably not very cost effective, and also it's quite a large design change. Overall, it's just impractical. So we probably would not want to add an additional column beneath the generator. All right, we have add downturned concrete beams beneath the generator. A downturned beam is an edge beam located under the slab perimeter. It is usually used in slab on grade situations. This would not be applicable in our case since the area in question is the roof and not the ground plane. Furthermore, adding a thickened beam element may also cause a change in ceiling height, which, as we notice here, the owner is concerned about maintaining the ceiling height in that unit. So this would not be a good option for us. Then we have increased the depth of the slab. This is actually the most straightforward solution. If there's too much load, let's just thicken the slab instead of 8 inches. Maybe we need a 10-inch or a 12-inch slab right under the penthouse here, and that would help carry some of that load from the emergency generator. However, again, we know that the owner is concerned about maintaining the ceiling height in that unit, so we can eliminate this option of increasing the depth of the slab. And then finally, we have add steel dunnage above the roof. So steel dunnage is a structural support system for mechanical equipment. This ties into the structural system and provides additional support for the emergency generator, addressing the increased load. By process of elimination, this is actually the best option. Even if you do not know what steel dunnage is, it is still possible to come to this answer by confidently eliminating the other options. So even if this happens all the time during the exam, especially, I know I came across this, but there are all those vocabulary words or terminology that I had never heard before, maybe had only heard once or twice and wasn't quite sure of their precise definition. You can use process of elimination in those types of situations to help work your way around the fact that you might not be completely confident about what a vocabulary term means. So our correct answer here is add steel dunnage above the roof.
Yeah, this is an interesting question that I wrote. This is actually based on a project that I worked on in New York City and have uploaded to Spectacular if you're interested in checking it out. But the situation's kind of made up. We didn't have this issue with the generator, but anyway, when you see a question like this on the exam, you might start reading through it, and maybe you're not that familiar with flat plate concrete construction. It's just not something you really focused on in your studies, not something common in your area, so you're not too familiar with it. You might want to skip this one until the end. I mean, it's kind of a longer question. It requires some comparing and contrasting of all of the choices. The answer is not going to be totally obvious until you read through all of the choices. So I would, if all that happened to me, I would probably skip it to the end. And the reason I say that is, if it's early on in the exam, you've kind of got to think about timing of each question, right? You've got about 2.5 minutes for each question. And if this happens early on in a 100-question exam, you might not want to spend 5-6 minutes on this question. But if you get to the end of the exam and maybe you've got a half hour left and only 5 questions that you flagged, you can kind of recalibrate your mind, and you know how much you can rethink about how much time you have per question. You add a little bit of comfort to your exam taking experience that way. So definitely think about skipping a question like this if it's not in your wheelhouse, I'd say. All right, let's move on to number 4.
Awesome. An architect is working on a mixed-use project with a new client during the programming phase. The project will primarily consist of an adult daycare facility on the 2nd through 5th floors, and the architect is assisting the developer in understanding what types of uses could be included on the ground floor of the project. The building will be equipped with an automatic sprinkler system in accordance with the 2018 IBC, section 903.3.1.1. Okay, so all of this is just saying we have a sprinkler system. Which of the following uses are permitted if a 1-hour fire barrier is provided? Check the 3 that apply. And then a little note here, questions like this on the area will likely be found in case studies with appropriate IBC codes provided as references. Refer to the 2018 IBC chapters 3 and 5 to determine your response. The question on the exam may or may not point you to what chapter you're supposed to be looking at. For our purposes, let's pretend that the question did not prompt us to go look in chapters 3 and 5. All right, so we are trying to find mixed uses that work with an adult daycare. This is a 3-part question. First, we'll need to figure out the occupancy type for an adult daycare. Next, we'll need to check the mixed use occupancies table to see which other occupancies could jive with our adult daycare. And then finally, we need to go back and look at which of the following options here fall under what occupancy groups. Okay, so let's go through all of that. So when you're looking at your IBC, actually I will scroll up and show, oh, okay, it's not here. There will be a menu over here that shows what the different chapters are, and during virtual workshops I always like to mention it's really nice to have a roadmap in your mind of what types of information fall under which chapters. If you have a general sense of that, getting to the information that you're trying to find in the IBC becomes much, much quicker. So if you can remember that chapter 3 is the chapter where you look at occupancies, that will really help you out. So in our question, we have an adult daycare facility. If you scroll all the way down to I, specifically section 308.5, we see that institutional group I4 would include both child daycare and adult daycare. So that's one way you could figure out what occupancy group the adult daycare would fall under. Another way, a much quicker way to do it, would just be to use the Control F function on the exam and just type in adult daycare. That will get you right there. So we know that we have an adult daycare and it's group I4. Okay, so we've got the first part of the question down. Okay, next we'll check the mixed use occupancies table 508.4, which is this table here, to see what other occupancies could possibly work with our I4 occupancy when using a 1-hour fire barrier. So let's go back to the question and remind ourselves here. We need to find out which of the uses are permitted if a 1-hour fire barrier is provided. So in this table, we're going to look at I4, which is here and here, and figure out which other occupancies would work with a 1-hour fire barrier. So let's look at this row here. For I4, we would trek across here. And find that we could use a B occupancy, an F1, an M, or an S1 with this 1-hour sprinkler here. And then if we look at this table in the column direction, we have I4 here. We see that we could also use an A occupancy and an E occupancy with a 1-hour fire barrier. Looking in both directions, you can also see that we could potentially use an R occupancy, we could use an F2, an S2, or a U. So anything in a row with I4 that has a 1 on it, or anything in this column here with I4 that has a 1 on it, those are the occupancies that we could potentially pair up with our I4 to be in that mixed use facility. All right, so we've done part 2. We know that we can use an A occupancy, an E occupancy, B, F1, M, or S1. Just a general note, be sure to read the table both ways. Not only would you have to read across in this row with I4, you would also want to read down in the column with I4. Okay, now we're on the third part of the question. We'll have to go back to chapter 3 to look at which of the answers fall under the occupancies that we've chosen. Actually, I think it would be helpful here if I just typed out really quickly the occupancies that pair up nicely with our I4. So we have an I4. We could also use an A, B, F1, M, or S1. Those would all work with our I4 occupancy in a mixed use facility. For the sake of time, we're not going to go back into chapter 3, but the way you would solve this is by looking up which occupancy groups each of these 6 potential answers belong to, and then cross-checking it with this list that we have here to see if it actually belongs to this list of A, E, B, F1, M, or S1. So we have a nursing home here that would fall under I1, a foster care facility. Oh, I'm going out of order here. So we have our nursing home is I1. We have our firewood storage facility, that's H3. We have our dry cleaner and bank. Those both fall under a B occupancy. Pharmacy falls under an M occupancy. And then our foster care facility is I2. Okay, so with all of that in mind, we know that we can choose our bank, our dry cleaner, and our pharmacy. So again, bank and dry cleaner were B occupancy. We've determined from that table 508.4 that we can have a B occupancy in a mixed use facility with our I4 adult daycare. So bank and dry cleaner are definitely correct options. And then we also have pharmacy. Pharmacy falls under M. M is one of our options that we can have in a mixed use facility with I4. So pharmacy is a great option for us as well. And then the other 3, nursing home was I1, which is not on this list. Fireworks storage facility is H3, which is also not on this list. And then we have foster care facility, which is I2, not on this list.
Yeah, this is definitely an example of a question type that you should really practice doing before you sit to take your exam. Even if you know how to do this, you probably want to practice doing it quickly on the exam, because there's a lot of back and forth between chapter 3 and chapter 5 to get a question like this correctly. Also using that Control F feature. If this was a case study question, you'll need to use that efficiently, just so you don't waste time on a question like this. I'll also note that, like, contrasting this to question 2 from earlier with the all water systems, right? We were able to, there's a way to kind of do some guesswork on this question. If you didn't really know it, you can eliminate all of the non-all water systems and maybe guess from there. I wouldn't go about this type of question 4, using sort of a, using sort of a guessing strategy like that. Hopefully you won't have to do that, because it might seem that nursing home or foster care facility would work really well, next to an adult daycare facility in this question, but that's not the answer. So you really do need to go through the code on this one and just be thorough about it and efficient. All right, take us home, Marissa.
All right, here we are, final question. A project architect is designing an accessible ramp for a municipal building and is reviewing the design parameters with the principal at the firm before getting started. The finished floor of the building is 35 inches above the parking lot, and the ramp will connect the two. The ramp will be constructed of dimensional lumber and will extend to the paved parking area, which will act as the bottom landing. What is the minimum run of the dimensional lumber ramp round to the nearest foot? Okay, so some keywords that are jumping out here. We want to find the minimum run of the ramp. The ramp is going to connect a building and a parking lot, and then the parking lot will act as the bottom landing. So this is a wonderful question for our whiteboard. We'd love to sketch this out just so we can see and visualize what is happening here. So we have our parking lot here, which acts as the landing. Just going to hatch this in. All right, parking lot here on the left. Then on the right side is our building. Okay, so some key things that we want to know about ramps, specifically ADA guidelines for ramps. One of the things we need to remember is that for the minimum ramp, length, we can have a rise of 1 for a run of 12. So that magic 1 to 12 ratio. So the question states that the rise of the ramp is going to be 35 inches. But we need to know what the length of that run would be. So because the ratio is simply 1 to 12, if you'd like, you can skip out on doing some math and just say a 35-inch rise is going to be the same thing as a 35-foot run. And I will also calculate this out. So we have our ratio, our ramp ratio here of a rise of 1 and a run of 12. That's going to equal our 35-inch rise over our run, which we will call X. When you multiply these out, we have X equals 35, I'm using the calculator now, 35 inches times 12, so that's 420 inches. And then if we want to translate the inches back into feet, we would divide by 12 and get 35 feet. So we know that the minimum run of the ramp is going to be 35 feet. Okay, some other things that we need to remember about ramps is that the question actually states that the total rise of the ramp is 35 inches. We need to remember that the maximum rise for any single ramp run is actually 30 inches. Since our total rise is 35 inches, we'll need to add a landing in the middle of our ramp to accommodate that 35-inch rise. So we can't do 35-inch rise all in one ramp. We need to split it up and do maybe a 30-inch rise, have a landing, and then do a 5-inch rise, or we could split it up more evenly and do maybe a 17-inch rise, have a landing, and then an 18-inch rise. But any way we look at it, we are going to need to add a landing here. And if we think back to our ADA guidelines, the minimum length of a landing is 5 feet. So we know that we're going to have a 5-foot landing somewhere in there. It doesn't matter necessarily for the purposes of this question. The last thing we need to look at here is just to reread the question carefully. So we know from the question that the ramp looks into the paved parking area, which will act as a bottom landing. So the bottom landing is already included in the parking area. However, the question doesn't state anything about the top landing. We cannot just assume that the building is going to provide the top landing for us, especially if you think about, exiting the building. The doors would likely swing out, and there need to be some sort of outdoor landing area before you can just start on a downward ramp. So we'll need to construct a landing at the building. The minimum length of that landing, again, is 5 feet. And then back to our discussion about the 35-inch rise, we're going to need to divide that somehow into two. So these two portions here. Oh, okay. Just gonna scoot back up here. Oh, I went to the wrong page, perhaps. Ah, I see, I'm really zoomed in. Okay. I believe we're on page 6, actually. All right, here we are. So again, our 35-inch rise needs to be divided into two because we can only have 30-inch rise at a time. So we know that these two segments here are going to add to 35 feet. So overall, our ramp includes a 35-foot long ramp divided into two. And then we have two 5-foot landings. The question is asking what is the minimum run of the ramp. So we have 35 feet plus 5 feet for one of the landings. And then plus another 5 feet for the second landing. All of that adds to a 45-foot long ramp.
Yeah, this is perhaps another question that you might want to wait until the end of the exam to answer because it's going to take some additional time. There's also, I just wanted to mention that there's definitely some information in this that you need to sort of commit to memory to answer this question. Specifically the 1 to 12 slope of an accessible ramp. That's something that that I would highly recommend memorizing for the exam, and I wouldn't rely on being provided with a code resource to be able to look up. It's also relatively simple to remember. The other really important piece of information here is the maximum rise of 30 inches for a ramp before a landing is required. That obviously is something that if you don't know, you'll get this answer wrong. You'll get 40 feet, I think you would get without adding that 5 feet in.
Mm-hmm.
So yeah, these are things that you've got to commit to memory. I get questions often about code related questions or accessibility related questions revolving around wondering if you'll be provided with this code information on the exam if you need to answer a question like this. And to answer a question like the one of the previous ones here where you needed to use table 508.4, that needs to be provided to you on the exam. You're not expected to memorize all the information in that table. It's unreasonable, and no architect has that committed to memory, I don't think. But accessibility, things like this, you certainly should commit to memory. I wouldn't bank on being provided with that information. It'll also help you out in your day job. If you're doing preliminary design for a ramp like this, and it'd be helpful if you didn't have to look up all the requirements. If you just sort of internalize them, you can obviously do it quicker that way. So we've got a few questions here, Marissa. I'll try to group them by, I'll try to stick to one question at a time so we don't have to pop around here. I'll do my best. If you could go back to, I think it was question 3, but the question about with the steel dunnage. And if you could just explain a little bit about how the steel dunnage works, like what's the goal of it. The specific question here was, is it supposed to distribute the generator load more efficiently over the slab rather than just placing it on the slab directly and creating a point load?
It does help take on more load. Chris, you're welcome to correct me if I'm wrong, but I like to think of it as if you've ever seen in some maybe more involved or larger projects, sometimes they'll actually put steel above the floor plate. as a way to help take on more load. I like to think of steel dunnage as something like that, where you're having like a top mounted steel and it's helping take on more load, and it's aiding the steel beams or whatever structural system is actually under that roof plane.
Yeah, that's exactly it. And on this project that I worked on, we did use steel dunnage under all of the mechanical equipment and the generator. And basically, the dunnage can span from column to column. And then you can place the generator anywhere along that beam, and it creates a point load that will be somewhere along the beam, and then transfer that load down to the columns that it spans between. It's actually pretty similar to the situation in that you drew on page 1 here, Marissa. If you were to just imagine the two columns being reaction R and reaction L here, and generators are heavier than 600 pounds usually, but you know, that point load might represent the generator in this situation. And the 200 pounds per square foot here, maybe that's the live and the dead load combined of the roof. This is a way of visualizing what we went through in that question. Don't think we had any more questions about that particular question. Let's jump over to the question about HVAC.
Sure.
We had a couple of questions about why hydronic radiant heating and cooling is not the correct answer, and just wondering, two people wrote in about this, wondering why it shouldn't be used in a hotel, and you know, if it can be placed on a wall instead of under the floor, so that you know, the carpet issue isn't a problem. I certainly have my thoughts on this one, but Marissa, if you have anything, let me know.
Sure. It could be placed somewhere that is not the floor. Definitely, I think that's a creative solution for sure. My other take on this is that it's generally intended for larger spaces, and hotel rooms are usually quite small.
Yeah, definitely. I've typically used this in large and like sometimes open spaces, like a loading dock. We might put something like this just to get some additional heating, you know, at a door that might be open often. Something to think about with hydronic radiant systems is they don't introduce any fresh air to the building. So they can't control humidity, like you said, and not introducing fresh air in a hotel is a problem, because in America anyway, most hotel rooms don't have operable windows. So you really want a system that's going to introduce some fresh air into a hotel room. Now, to be totally honest, I've been in hotel rooms overseas that used hydronic radiant heating and cooling. I think specifically in Iceland, and that room, if I remember correctly, had operable windows, and it was a low-rise building. So one thing to remember is this is a US-based exam, so think about you know, how building conventions in the US specifically when you're taking this. And I think the last thing I'll say about this topic is this question, and I wrote it, is specifically taken from the Architect Studio Companion, which is an ARI resource. And that book, just trying to find it now, I think on page like 384 or something, it has a really helpful chart about common systems and what types of buildings they're often used on. I would definitely familiarize myself with that chart. We also cover it in our materials, but the point that I'm getting at is think about how the ARI questions are created. They're created by somebody who is trying to find information in the resources that are listed in the ARI handbook that can be tested on. So all of the information behind these questions comes from a book. So the answers that you have to think of really need to be grounded in one of those resources listed in the book. That's one of the reasons why on all of our practice exams and our quiz questions and everything, we list a resource where that information came from. It's a really helpful reminder of how the questions are made. And for me, when I was taking the exam, I always wanted to try to put myself in the mind of the person writing the question. Because the answer has to be really justified in a book at the end of the day. Moving along, the question about table 508.4. We had one question. Well, somebody was asking how is the 1 hour fire separation determined, and I just want to point out that that is sort of at the tail end of the question there. So that's how that comes up. We also had a question. We had two questions related to why foster care and nursing homes are not correct. I believe that they are able to be provided without a fire barrier at all. So Marissa, why would you say that as a test taking strategy, why would you say that those aren't correct on this question?
Well, if we look, let's look back at the table. So we have, let's see, foster care facility. What did we call that as? We called the foster care facility to be an I2. We have I2 here, and we have our I4 here. So when we see those, it doesn't mean that you can't build a facility that has an I2 next to an I4, for example. You would just need to have a sprinklered building, and it would need to be a 2 hour fire barrier instead of a 1 hour fire barrier. So this question here isn't saying you can only have a dry cleaner, a bank, and a pharmacy next to the I4. What the question is saying is, if you had a 1 hour fire barrier, which uses could you have adjacent to the adult daycare facility? So in a different scenario, if the question asked, you know, which of the following uses are permitted if a 2 hour fire barrier is provided, then definitely you could use a foster care facility. But this is kind of like the linchpin of the question here. It's the determining factor of how you would be able to read this table.
Yeah, I would also say if one of the options here in this question didn't require any separation, right? But three of the options required exactly a 1 hour separation. I would pick the three that required a 1 hour separation just based on the question that's specifically asking about that scenario. I know in real life, obviously, if you can provide more than is required by code, that's totally allowable. But again, just to get at the idea that these questions are written by somebody who's looking to test you on a specific piece of information. In this case, if you can read this chart and understand which ones require exactly a 1 hour fire barrier. So always have that type of a thought process when you're going through the questions. We had a sort of a procedural question asking somebody that had never taken the exam and just wondering how we can flag a question and skip and come back to the end. So I can take that one. It's relatively simple and something you should think about, but you can use that mark for review button at the lower center part of the screen. And you can mark as many, and see it has that little flag icon. You can do that for as many questions as you want, and then when you, if you were to be on the real exam and click the exam summary, those questions would pop up with a little flag next to them. And you can also just review all of your flagged questions at once, or you can click into them individually. That's a really important thing to be able to use. What I will say is if you plan on taking a break, those questions are going to be locked when you come back from a break. So either review your flagged questions before your break, or don't plan on taking an actual timed break, so you don't lock yourself out of some questions. Going back to the very first question here, somebody was wondering why, if there's a way to do that type of a calculation in one step as opposed to two, I guess where you combine the point load and the uniform load. Have you ever done it that way, Marissa?
Probably during college.
Yeah.
I think it's possible. You just, like many of the things that you mentioned after we went through the question, you just need to make sure that you're being precise about things and not mixing up your units or mixing up the uniform load with the point load. I think it can be done, but I find it easier to separate things out and make sure I know exactly what I'm doing and then just add them together at the end.
I agree. I think you can, if you're going to put in the time to answer this question, you might as well get it right. So why don't you take, like, if you're really comfortable doing it in one step, that's great, and you can do that on the exam. But I would do it in 2 steps, even if I was, just to make sure that I'm not crossing something up. on this particular question. And then somebody else asked if you could just go over again why the point load on the left end equaled 0 in this question.
So we're taking the moment at the left reaction. And again, taking the moment is a fancy way of saying multiply the load we're thinking about by its length from where we're taking the moment. So we're taking the moment right here. So if we think about all of our loads acting on this beam, we have for just the point load, actually, not thinking about the uniform load right now, we have our 600-pound point load, we have the right reaction, and we have the left reaction. So the right reaction is 16 feet away, the point load is 4 feet away. But since we're taking the moment right at the left reaction, the distance it is from the point we're taking the moment is 0. So we don't need to think about the left reaction. This way of taking the moment is a nice way to kind of cancel out one of the unknowns, because we're trying to find the right reaction, but we also don't know how much load the left reaction is taking. So when we take the moment, if we can cancel out the left reaction, then we're just left with one unknown variable.
Yeah, that's a great explanation of it. It's and it kind of goes back to just getting getting comfortable with statics before you go into these exams and kind of understanding the theory behind it. That's one of the key points that points in the theory of statics that Marissa's talking about. I think also she mentioned making sure you have your negatives and your positives straight when you're writing out these calculations. That's something that I would recommend practicing. I like to think that it helps me to think about that by thinking of like counterclockwise versus clockwise reactions about that moment. So the 600 pounds is operating clockwise, whereas the right reaction is operating counterclockwise, if you were to just sort of draw those out about reaction left. That might sound confusing if you're not familiar with it. But I promise it does make sense if you practice it, and if you follow along with what Marissa's drawing on the screen right now. It's pretty clear, I think. So get comfortable with that. It's statics are this kind of scary topic, I think, that people are worried about. But it's not. I promise it's not that complicated. The math is actually pretty straightforward math if you can get the formula correct that you start with. Obviously, if you don't get the formula right, your answer is just not going to be correct. Just the last few questions here, all relating to the last ramp question, and then we'll wrap this up. Two of the questions are asking about the bottom landing. So shouldn't we add the 5 feet at the bottom of the ramp? And yeah, what do you think about that one?
So the question mentions that the ramp is going to extend to the paved parking area, which will already act as the bottom landing. It's also asking for the minimum run of the dimensional ramp. And let me see if there's anything else. Dimensional lumber is also another hint that, this ramp is going to be constructed out of two things that seem to be already existing. And so we just want to know about what is getting newly constructed, not, the entire length of the ramp. I think with those 3 hints, I'd be pretty comfortable saying exclude the bottom landing.
Yeah, that's exactly what I'd say. And the reason that dimensional lumber shows up in the question itself here is that's kind of the hint so that you don't include that bottom section of the ramp. This is something that comes up a lot when you're asked to calculate the length of a ramp, and there's always some confusion about including landings and not including landings. And I tried to make that clear with this one, with specifically saying that the bottom landing will be paved and asking about the minimum run of the dimensional lumber portion of the ramp. So that's kind of just a reminder to really carefully read that question. Specifically, I don't know if you've ever noticed this about ARI questions, but this top portion here that's like a paragraph, we call that the stem of the question. That kind of provides background information. And then the question itself is on a different line. and is separate from the stem of that question. So I would definitely like reread that question itself, the last line here, a couple of times, and wonder what is being asked, and try to approach it that way. So I think that's it for today. Be sure to tune in on October 20th, 2022, as we review questions from the PA, PPD, and PDD divisions. We'll focus on solving complex math questions that you come across in these three divisions. Our expert discussion with returning guest Haley Pugh will include a live demo of how to effectively use the whiteboard and calculator for these multi-step math problems. We'll also offer a live Q&A session to answer any of your mathematical questions. We'll be sending out a mock exam link in the coming weeks so you can test your knowledge before going over your answers live during the broadcast. I'll post the link to register in the chat box in your GoToWebinar control panel, or you can go to go.blackspectacles.com/ARE-live to sign up. As I mentioned at the top of the webinar, Black Spectacles offers the first and only ARE pass guarantee. We're so confident that if you use our expert membership to the fullest, you will pass the ARE. And if you don't pass, we will pay for your retake. To learn more about how to qualify for the guarantee or to check out individual membership options, head over to go.blackspectacles.com. And I just shared the link to learn more about the guarantee in the chat. Don't forget to join Spectacular, the professional network for architecture and design. We built this platform for you to showcase your portfolio, seek inspiration, network with architects and firms outside of your local community, and help you find your dream job. Head to spectacular.design to create your free profile and upload your best project today for the opportunity to be featured on our homepage. I just shared the link to register in the chat. The lucky winner of our Black Spectacles t-shirt is A. Champagne. We will reach out to you via email to get your size and shipping information. And just as a reminder, if you'd like to be eligible to win a t-shirt, post a question you have about our featured topic in our community during our next ARE Live. And our community is always buzzing. It's not just during ARE Live, so poke around and see what your fellow architects are up to and asking about. Just a reminder that this episode will be available in both podcast and video format after the airing. So to get the full experience, you can watch the video on our website, blackspectacles.com, then go to resources and then ARE Live podcast. Finally, be sure to stick around for a few minutes and take our survey and share any suggestions you may have. I promise we read every word that you write and use them to fine-tune our upcoming episodes. Thanks for watching.